Okay, so where we left last class was we started doing applications of derivatives, and we ended with exact cost and marginal cost. Two totally different things, okay? So let's start with exact cost. Exact cost is no derivative, no calculus, nothing like that. If you're trying to find the exact cost of the 121st bicycle, you would find the total cost of the 121st, you would find the total cost of 120, and then you would subtract those values, okay? So no calculus, no derivatives, nothing like that. Exact cost is the cost of 121, the cost of 120, and then subtract them. So I'm going to go to the calculator. I'm going to go to y equals, and a good habit is to make sure you have a clean calculator. So nothing in y1. Notice I have the plot highlighted, so I'm going to go up to it, hit enter, make sure that all your plots are off, nothing in y1, nothing in y2. And then in y1, I put 10,000 plus 150 x minus 0.2 x squared. Now remember, x is the number of bicycles, and this is going to tell us total cost. So we're trying to find the total cost of 120, the 121st bike. Okay, so I put the cost in y1. I go to the table, second graph. I put in 121, and I will tell you that the calculator does round. So if you use that number, that's fine. But if you actually put your cursor on top of the number, you get the exact number, 25,221.8. 25,221.8. So 25,221.8. Then we're going to find the cost of 120 bikes. So the cost of 120 bikes is 25,120. 25,120. Now, why does this work? Well, this is the total cost for 121 bikes. If I take away the total cost for 120 bikes, you're left with just the 121st bike. So when you do that, and I'll actually show the work. $25,221.80. 25,221.80 minus 25,120. You are left with just the 121st bike, which is 101.8. 101.8. 101.8. Okay, so if I was going to write this in a complete sentence, real quick, just practicing, doing all of it, the exact cost of the 121st bike is $101.80. Okay, so again, exact cost, no derivatives, no calculus, nothing like that. It's just exact cost. Now, marginal cost, which is a similar idea, but this is using derivative. Anytime you see marginal means take the derivative. Take the derivative. So we have our cost is 10,000 plus 150x minus 0.2x squared. So we first have to find marginal cost. The derivative of 10,000 is 0. The derivative of 150x is 150. And the derivative of 0.2x squared is 0.4x. Now, this is where we got to be careful. Since we're looking for the cost of the 121st, we're not plugging in 120. We're plugging, 121. We're plugging in 120. Because remember, This is how the cost is changing. This is how the cost is changing. So when I plug in 120, we're stopping at 120. It's the cost of the next one. We've made 120 bikes. The next one that comes off the line, how much will that be? So if I want to use the calculator and really use the calculator, I'm going to go to y equals, and in y2, I'm going to put the derivative. The derivative is 150 minus 0.4x. And I can check the derivative by going to y3 and doing math, 8, depending on your calculator. This one is x, vars, y vars, 1 for function, y1 is the original, that's what we're taking the derivative of, and then x. If you have the other form of the calculator, it's y1, comma x, comma x. So learn your calculator. And if I do this correctly, go to the table and plug in 120, y2 and y3 should match. Doing it by hand and doing it in the calculator are the same. And you get 102. Now, notice they're very close to each other. 102 and 101.80. Very close to each other because they mean basically the same thing. They mean basically the same thing. Now, there are two ways to write this. The way I like to write it for this one is I would put at 120 bikes, the cost is increasing $102 per bike. That reminds you that this is a rate of change. Cost per bike, cost per bike. It's how it's changing. We've stopped at 120, the cost of the next bike. But again, the other way of writing it, which is also correct, the cost of the 121st bike is $102 because it's the cost of the next bike. Just be careful. But again, I like the cost per bike, because it reminds you that it's changing. It's changing. It's a derivative. Derivative is rate of change. Okay. So we're just going to keep going and we're going to do some more word problems and we're going to do this one. Okay. A company's market research department recommends the manufacture and marketing of a new headphone. The research department presents the following price demand equation. So here they give it in terms of X. Remember X, again, always know your input and output. X is number of headphones. So we're talking about headphones. Okay. So this one is in terms of X. X is how many. So if you tell me the price, I'll tell you how many headphones. But for us, our ultimate goal is we want to find revenue. So since we want to find revenue, we're going to do a little bit of algebra and convert this to solve for P. So I'm not going to go ahead and do the algebra on how I solve for P. That's just algebra. But let's just say we started with this. You tell me how many headphones and I'll tell you the price. You tell me how many headphones and I'll tell you the price. But what I really want is to find the revenue. So let's be very clear. Is this equation, which I just gave you, is that revenue? Nope, it's price. So how do I go from price to revenue? Price to revenue. We talked about this before. Remember, revenue is price times demand. And again, what's a quick example of that? If you tell me how many pizzas we sold, 100 pizzas, the demand is X. And then you tell me price, how much I sold each pizza for, $9. You now can figure out how much money we made. 100 times 9, we made $900. Good so far? So this one we know, but we need to know to use it. So to find revenue, I have to take price. Well, price is 10 minus 0.001x times how many, which is x. So even though revenue wasn't given, the pieces to find revenue were there. I told you price and I told you x. So that's something you do need to know. Revenue is price times x. Revenue is price times x. So when I clean this up, you're going to have revenue of 10x minus 0.001 x squared. So this formula, again, we had to do a little bit of work to get it. It wasn't given to us. We had to do a little bit of work to get it, but that will tell me revenue. You tell me how many headphones, I'll tell you how much money we made. Okay? So to take off what we did last time, we're going to take this and add some stuff to it. I want to know what is the revenue at 2,000 headphones. What's the revenue at 5,000 headphones? And what's the revenue at 7,000 headphones? And you're like, all we're doing is plugging it in. Perfect. That's exactly what you're going to do. But then I want you to find the derivative of revenue, which is called marginal revenue. And we're going to do the same thing. We're going to find, give a little space here, the marginal revenue at 2,000 and explain it. The marginal revenue at 5,000 and explain it. And I'll try to squeeze it in here as well. The marginal revenue at 7,000 and explain it. Okay, so the math part of this is what happens to the revenue at 2,000 headphones, 5,000 headphones, and 7,000 headphones. Take the derivative of revenue, plug in 2,000, 5,000, and 7,000. So the math part may not be that bad. The hard part is, what does it mean? Why would you do it? Okay, so give it a try, use the calculator, do the work, blah, blah, blah. See what you can get. So notice that the first part is just plugging in the numbers, right? So I'm going to go to the calculator, go to y equals. I'm going to change y1, get rid of y2. I'll leave the derivative there for now, so I don't have to retype it. But now we're dealing with revenue. Revenue is 10x subtraction 0.001 x squared. Okay, so I'm going to go plug in 2,500 to 2,000, 5,000, 7,000. So if you go to the table, plug in 2,000. Again, everything has meaning. 2,000 is 2,000 what? Headphones. So at 2,000 headphones, what's 16,000? Total revenue. So if you, I'm not going to write this one, but I'm just going to do these. If you sell or you sell 2,000 headphones, you will have a profit, a revenue of 16,000. 16,000. Good so far? Now, if you sell 5,000 headphones, you'll have a revenue of what? 25,000. Okay, this is good, right? The more you sell, the more money comes in. Okay, so you're like, this is great. Then you sell 7,000, and you get 21,000. Just looking at Y1. So hopefully you paused for a second and you're like, something's going on here. I thought, and I believe, the more you sell, the more you produce, the more money you make. This is telling me I lost money. What is going on? What's happening? How can I lose money if I'm selling more? We'll talk about that in a little bit. So when you do the derivative, when you do the marginal revenue, The derivative of 10x is 10. Minus the derivative of 0.001x squared is 0.002x. Then we're going to plug in 2,000, 5,000, 7,000. So I'm going to do this all in the calculator. And when we do that, we're also going to check it. So I go to y equals, I go to y2, and we get 10 minus 0.002x. Go to the table, second graph, and y2 and y3 match. That makes me feel pretty good. And I get 6, 0, -4. Okay. 6, 0, -4. This is where we're going to pause. So yes, you can do the work and get the right answer. The question is, what does it mean? So I'm going to do the first one with you, and then we'll talk about it. So for the first one, I'm going to put at 2,000 headphones, the revenue is increasing. Why am I putting increasing? Positive $6 per headphones. Yeah. We're assuming you're getting 2. Sometimes they do sell 1 actually. Okay. So what's going on? I stopped my business. We've sold 2,000. I can see my total revenue, but this is telling me the very next headphone that I sell, what's going to happen to my revenue? It's going to go up. I don't know about you, but do you want more money? Yeah. So you're like, okay, cool. So instead of 2,000, let's sell 5,000. So you up it. Okay, now watch what's happening. I'm literally copying this sentence. Copy. And I'm going to paste it right here. And now I'm going to say at 5,000 headphones, the revenue is, it's 0. So it's not increasing or decreasing. It's now $0 per headphones or headphone. Get the idea. Okay, so wait a minute. This is telling me now I've produced 5,000. If I produce more, what's going to happen to my revenue? It's not going to change. So should I do more? No, you should stop. I'm only going to do it to make more money. I'm not going to do it to make less money, but you didn't see the signs. You didn't see what was going on. You have the belief that the more you produce, the more money you'll make. So you now go to 7,000. I'm going to copy and paste. Well, actually, I already did. I'm going to paste it. Oops. Now at 7,000 headphones, the revenue is now decreasing. I'm losing money. Decreasing 4. Now, please note that I put decreasing. I don't put decreasing negative. I just put decreasing 4. And I apologize, it's not the best location. Okay. So at 7,000 headphones, my revenue is now going down every headphone $4. Is that a good thing or a bad thing? Bad thing. Now, let's talk about why we believe this. We believe the more you produce, the more money you make. I think I've told you this story before. My parents had a pizzeria for 10 years. Our ovens, you could put 6 on the bottom, 6 on the top. We could easily produce 12 pizzas like that. Somebody walks in and wants 100 pizzas now. We can't do 100 pizzas now. We can do 12, 12, 12, 12. Takes about 10, 15 minutes to cook. We got to make it, blah, blah, blah. It's going to take a while. So if I had to produce it now, beyond our limits, I'd have to call another pizzeria. I got to pay their price, or I got to buy another oven. There goes all these expenses come up because I can't produce that much comfortably. So if you go beyond your means, your costs go up. You don't make any money right now. So this company, what's a good place to be? 5,000, not 7,000. Maybe you're paying your employees overtime, time and a half, double time, all these things. What happens to your money? It goes away. Does that make sense? So this is telling you, stop at 5,000. And if you don't listen, look at your data. If you don't listen, look at your data. Look at your revenue. It went up and it went down because you're now losing money per headphone. Does that make sense? And how do we see that? We see that with the calculus. We see that with marginal revenue. How is your revenue changing? Is it going up? Is it going down? Or is it staying the same? To finish this problem, let me go ahead and graph it. Now remember, we're talking about 2,000, 5,000, 7,000 headphones. Keep that in mind. And my revenue is 16, 25, 21,000. Are we okay? The reason why I mentioned that is when I go to graph this thing, I'm going to go to y equals, I'm going to turn off y2. I'm going to hit enter on the equals, and I'm going to turn off y3, hit enter on the equals, because I only want to graph the revenue one. I only want to graph the revenue one. And my window, and again, we've talked about window before. Window, X is how many headphones? I'm going to go from 0 to 10,000. Why am I going from 0 to 10,000? Let's say counting by thousands. Because look at the numbers I plugged in. 2,000, 5,000, 7,000. Does that cover that? Yep. The Y is the revenue. So the lowest revenue is 0. The highest number I saw was 25,000. So how high should I go? 30,000. Perfect. Again, this is where the window comes from. Nobody gives it to you. You just kind of understand. And let's count by 5,000s. So what happens when I hit graph is you see the revenue going up and the revenue going down. That revenue is not going to go up forever, right? At some point, it's enough, right? Do you really need, when you go to the store, 10 million shoes? Or if you had a selection of 50, if the store had to hold that many, you see the problems, flooding the market, all that, okay? So when I hit second trace, number 1 for value, at 2,000 headphones, and again, we're looking at the original, notice it's still going up at that point. That's why your derivative is positive, because derivative is rate of change. It's going up at that point. When I plug in 5,000, conveniently, where do we end up? At the top. And at that point, you're level. Because when you go to 7,000, now we're going downward. We're losing revenue. And you can see this is revenue. This isn't the derivative of revenue. We're just looking at the original right now. This is all about the original. Are we okay? But see how we're taking graphing, calculator, word problems, algebra, and now adding derivatives. It's all building, building, building. But hopefully it's to say, hey, company, here's a picture of our revenue. We shouldn't be producing 7,000. We shouldn't be producing 2,000. Based on the data, we should be producing 5,000. That's a good, comfortable place for us, for the market, for our money. Make sense? And do they do stuff like this? Absolutely. Because if you mess up and sell too little, you lost money. You could have made more. If you put out too much, you've lost money because nobody wants that much. You're putting too much out there. Are we okay? And the whole world works with price and demand. If you have the wrong price, if you have too much product, everything is wrong. The idea is to get it all right. Okay? So we're going to take this idea, and I don't want to do it over and over and over again, but I do think we're on the right tracks. I want to practice a couple things. So I'm now going to throw in, because some of you guys brought in cost. I'm now going to bring in cost. So you are given cost. So we have revenue. Revenue was 10x minus 0.001 x squared. I'm now adding to this. We know our cost is 7,000 plus 2x. Now, I don't want to spend too much time doing the same thing over and over again, but I do want to test your algebra, your calculator, and now your understanding. So in a quick way, mostly calculator, mostly discussion, I want you to find the profit equation and plug in 2,000, 5,000, and 7,000. And I want you to find the derivative of profit. Plug in to the derivative 2,000, 5,000, and 7,000. So it is the same problem, except we're talking about profit, and be careful with your algebra when you find profit. But we'll have more of a discussion instead of me writing everything down, because the steps are all the same. We're just doing it again. But I'll give you a couple minutes, find profit, because if profit's wrong, everything's wrong. So be careful. So this did not give you profit. This gave you revenue, and it gave you cost. You need to find profit. You need to do the algebra, and if that's wrong, everything's wrong. So be careful. Remember that profit is revenue minus cost. And yes, I'm putting parentheses for a reason, because it's revenue minus cost. So to find your profit, it's 10x minus 0.001x squared minus 7,000 minus 2x. And now those details really, really matter. So if you put this in order, your profit is going to be negative 0.001x squared. 10x minus 2x is plus 8x minus 7,000. If that profit is wrong, everything is wrong. And the reason why you'd get it wrong is algebra. Okay, so I did this problem specifically to test your algebra. Okay, now, once you have profit, we then can find the derivative of profit, which will be marginal profit, would be negative 0.002x plus 8. So to save a little time, we're going to do all of it at the same time, and we'll just have more of a discussion about what it all means instead of writing it down. Okay, but I'll be happy to write it down if you need to. So let's go to the calculator. Go to y equals. Get rid of y1, get rid of y2. And now in y1, I put total profit. Total profit is negative 0.001x squared plus 8x minus 7,000. Enter. We're going to put the derivative, which is negative 0.002x plus 8. So we're checking everything in the calculator by doing the y3. So make sure your y3 equals is on. Hit enter on top of it. So all three are highlighted. And now into profit, we're going to plug in 2,000, 5,000, 8,000. So I go to the table. We already have the numbers in there. Let's talk about each one separately and make sure we're careful. At 2,000 headphones, your profit is $5,000. Profit, revenue minus cost. At 5,000 headphones, your profit is $8,000. Money in your pocket. At 7,000, what happened to your profit? What do you get? 0. So in terms of profit, at 2,000, should we make more headphones? Yeah, we should totally make more. I want $4. Don't you want $4? I'll take a penny. I'll take anything, right? At 5,000, should we keep going? No, because if I do, what's going to happen to my profit? So now, using the calculator, the table feature, how many should I produce for profit? How many should you produce? How many sets of headphones for profit? When should I stop in terms of profit? So here's the question again. At 2,000 headphones, the marginal profit is +4, which means you make an additional $4 on that next headphones. So produce more. You kind of overshot it. You went to 5,000 and now you're losing $2 for every set of headphones. So we know it's more than 2 and we know it's less than 5. We overshot it, right? So you tell me, how many should we have stopped at? 4,000. If we plug in 4,000, couple things. Notice the profit. That's the highest number we have. And if I produce another one, what's going to happen to my profit? You're not going to make any more money. So should you keep going? No. This tells you where to stop because you're seeing how your profit is changing. So again, I didn't write everything down. I didn't write sentences, all that stuff. It's very similar to the previous one, but I want to reinforce that thinking. And be careful with the algebra. Be careful with the algebra. So the last topic we're going to talk about is not really a derivative topic or anything like that. The last topic we're going to talk about is called average cost. Average cost. Average cost. It could be average cost. It could be average revenue. Or it could be average profit. But hopefully you're comfortable with the word average. If you want to do average cost, the symbol for average cost is a bar over the C. If anybody of you had statistics, X bar is mean. C bar is average cost. And this is a mistake. That bar shouldn't be there. You take cost divided by X. That's it. There's no derivative. There's nothing special. When you find an average, it's total divided by how many? Okay, same thing for revenue. If you want to find average revenue, that's our bar, revenue with a bar on it, right? You just take revenue and divide by X. That's it. You divide by X. If you want to find average profit, that's with a bar over the P, you just take profit and divide by X. So all I'm teaching you right now is average cost is cost divided by X. Average revenue is revenue divided by X. And average profit is profit divided by X. So if you haven't caught the theme yet, you just divide by X. It's finding the average. When you find the average of something, you add them all up, you find the total, and divide by how many. How many is X? And you're like, wait a minute, he's going to throw a derivative in there. I will, but not yet. Okay? So let's just start really slow, really slow. The total cost of printing X dictionaries. Dictionaries are these books we used to have with all these words, right? We don't do dictionaries anymore. But it's not a business to get into, put it that way. So this is the cost where we know that X is number of dictionaries. Number of dictionaries. What I would like you to do is I would like you to find the total cost of 1,000. I want you to find the average cost function and then the average cost of 1,000. And I'm just going to give you a little head start. I'm not going to let you go too far, but see what you can do with that. See what you can do with that. So we're going to find the total cost of 1,000 dictionaries, find the average cost function, and then what's the average cost for 1,000 dictionaries? Just giving you a head start. Haven't taught it yet. See what you figure out. Nice and slowly. Let's just get rid of everything we have. We're going to go to the calculator, get rid of Y1, get rid of Y2, get rid of Y3. Let's start nice and slowly. I gave you total cost. Total cost is 20,000 plus 10x. Everybody comfortable with that? And I asked you, what's the total cost of 1,000 dictionaries? So you go to the table, you plug in 1,000. Again, nothing to do with calculus or anything like that. You plug in 1,000, you get 30,000. You get 30,000. So in a sentence, 1,000 dictionaries cost $30,000. Good so far? Nothing special there, correct? We just took 1,000 and plugged it in. That's all we did. We good? Then I asked for average cost. Let's keep average cost very simple. Average cost is cost divided by X. That's it. You take cost, excuse me, and divide by X. So I'm literally going to put that in my calculator. I'm going to put that in my calculator. Okay? So I'm going to go to my calculator, y equals, I'm literally going to put parenthesis, 20,000 plus 10x, close parenthesis, divided by x. That's average cost, right? It's just cost divided by x. If it was revenue, revenue divided by x. Profit, profit divided by x. It's just cost divided by x. Good so far? Now, I do want to point out, some of you may have thought, ooh, I know a shortcut. Anybody know a shortcut to this? Where's cost? Where is it? What's it called? No, where is cost? Why one? Oh, couldn't I just do vars, y vars, function y1 divided by x? If you want to be a little lazy, not write it again. Aren't they the same thing? Right? And so when I plug in to the table 1,000, you now get what? 30. The reason why you get $30 is this is the average cost for 1,000 dictionaries is $30 what? Per dictionary, right? That's not the total for all of them. That's the average cost. Now, again, the first one may be expensive, the last one may be cheaper, but on average, what's the cost per dictionary? $30 per dictionary. That's the average cost. Are we okay? Total different thing than marginal. This is average cost. Have I done any derivatives, anything at all? No. And we could stop here and we stop happy, but we won't. Because what if I ask for marginal average cost? Bum, bum, bum. That means I don't want average cost. I want what? The derivative of average cost. So again, let's make sure we got all the vocabulary correct. It doesn't ask for marginal cost, which is the derivative of cost. It asks for marginal average cost. So you have average cost right now. Here's average cost, 20,000 plus 10x over x. And our last question is going to be, which again, this is the thinking. If you can do the basic one, fantastic. But as soon as it gets a little harder and you fold, that says you got to practice a little bit. So the only hint I'll give you is that you need to take the derivative of that. And in order to take the derivative of that, you need to what? Rewrite it first. Rewrite it, then take the derivative, then check, because our last question is, what's the marginal average cost? Marginal average. So I got the bar and I got the apostrophe. I got the bar and the apostrophe. So we're doing average and we're doing derivative. What's the marginal average cost at 1,000? So we changed it from cost to average cost. Got that, cost divided by X. Now I'm asking for marginal average cost. And the way it's written, I can't take the derivative of it. I got something divided by X. So is there a way to rewrite it so it's easier to deal with? And the answer is yes. It's called algebra. What's being divided by X, first or second? Both. 20,000 over X plus 10X over X leaves you with what? 10. And again, if you're not sure how I got that, 10X over X leaves you with 10. Bless you. Are we okay? Now, if you're like, ooh, I've never done that before, we did it in the notes. I promise you. One of the ones we had to rewrite was like this. Promise you. Okay? Now, see that X on the bottom, that X to the 1? It's still a problem. How can I rewrite that? Move it up, and it becomes a -1. So I didn't do any derivatives. I didn't do anything. All I did was rewrite it with algebra, excuse me, with algebra. Now we can take the derivative. So this is going to be the derivative of average cost. This would be -20,000, X to the -2. What's the derivative of 10? Derivative of 10? 0, right? So -1 times 20,000 is -20,000. -1 minus 1 is -2. We should all be comfortable with that. Derivative of 10 is 0. This is your derivative, which can also be written as -20,000 over X squared. Now, there's your derivative. Let's check it in the calculator. Go to y equals, and let's change a couple of things. Let's, well, I'll leave it all there. There's cost. There's average cost. We just figured out that the derivative is going to be -20,000 divided by X. Now be careful, be careful. Are we taking the derivative of y1, which is cost, or the derivative of y2, which is average cost? Y2. So I'm going to do math 8 X vars y vars function y2 X. So let me be very clear. Y1 is cost. Y2 is average cost. Y3 is the derivative. Oops, X squared, right? Forgot the squared. The derivative of cost, derivative of marginal, the marginal average cost, and then this is the calculator doing it. So when I go to the calculator, which ones should match? Y3 and Y4. Okay, so again, cost, average cost, marginal average cost in the calculator. When I go to the table, we're going to talk about everything. Ready? One at a time. What does 1,000 represent? 1,000 dictionaries. What does 30,000 represent? Total cost. What does Y2, $30 represent? Average cost. Now hold on, let's stop there. I've made or produced whatever it is, 1,000 dictionaries. My total cost is 30,000. On average, the cost per dictionary is $30 each. Are we okay? Is that average cost going to be the same forever? Is that average cost going to be $30 till the end of time? No, that average cost is going to change. And this is telling me, how is the $30 going to change? It's going to go down 2 cents. That average cost is going to get cheaper. Over time, the next one you make, it's going to get cheaper. Okay? So you get -0.02. So if I was going to write this in a sentence, the average cost at 1,000 dictionaries is decreasing 2 cents per dictionary. Again, it's how the $30 is changing. It's how the $30, the average cost, is changing. So that's it. We are done with chapter 2. And what you have next is the review. So I just want to walk through the review real quick. Remember, it's been a while, but we've done limits. We've done vertical and horizontal asymptotes. We've talked about continuous, limits, vertical and horizontal asymptote, continuous, limit, vertical and horizontal asymptote, continuous. We've also talked about average rate of change. We used 3 different formulas, leading us to the derivative formula. There's a couple of those to practice. Then we learned the shortcut method. And now we're going to talk about what the shortcut method means, or what the derivative means. But we're going to practice taking derivatives. Could be a simpler one, could have a fraction, could have a negative, could have a square root. Be comfortable with everything. Then we did derivative word problems, plugging into the original and plugging into the derivative. Exact cost, marginal cost, what it means in a sentence, average cost. We just did that today. And then you can compare the numbers. This is another word problem dealing with profit, marginal profit, talking about workers. Should you hire or fire workers based on the profit? If the next employee gives you more money, hire. If the next employee loses money, you got to fire. Okay. Number 12, I do want to point out, 12 is probably my favorite problem, but the problem you're not going to like the most, because 12 doesn't give you the equation. All the other problems, here's the profit, here's the cost. This one does not give you the equation, because what you're learning is the equation doesn't come from the sky. The equation comes from data. So I gave you the data. You're going to put it in list 1. You're going to put it in list 2. And this one says you're going to do quadratic regression. And when you do quadratic regression, that quadratic regression will give you the equation. Once you have the equation, then you can do the problem. But number 12, the equation is not given to you. Number 12, the equation is not given to you. You have to do quadratic regression to get the equation. Once you get the equation, it's like all the others. Okay? But this is reminding you that no one just hands you the equation. You collect data, you look at the data, and you get the equation by doing the regressions. We learned linear, quadratic, cubic, quartile, exponential, logarithmic. We learned a lot of regressions in here. Okay? And with that, that ends the review. Now, your worry may be, this is, I'll be honest with you. This is the derivative the long way. The long way. Okay? Don't worry about it unless you want bonus. That will be a bonus. Remember the long way with all the algebra? That will be a bonus on the test. Okay? Now, please note, actually, I'll stop. We'll stop the recording there.